Hello, guys. We're gonna start now. Let me just check if it's recording. Okay, it looks like it's recording. Let me check again. Okay, it's recording. Guys, hello. We are going to discuss integration. In this session, we're gonna discuss integration. Okay, so in this session, we're discussing integration. Let's write it down. Integration. Integration. So in this session, we're discussing integration. Okay. Integration. And we start with indefinite integrals. So we kick off with indefinite integrals. Let's kick off with indefinite integrals. All right, so we're discussing integration and we're starting with indefinite integrals. Okay, so let's start with a statement that integration is the reverse of differentiation. That's what integration is. Integration is the reverse of differentiation. Okay, we're going to look at examples to see what this means exactly. Let me write it down first. We have that integration is the reverse. Integration is the reverse of differentiation. Integration is the reverse of differentiation. Integration is the reverse of differentiation. Let's look at examples to see what this means exactly. Let's look at examples to see what this means, okay? Number one, suppose that we want to integrate the number 2. Okay, so remember we said integration is the reverse of differentiation. So now suppose we want to integrate the number 2. We want to calculate the integral of 2. The way we denote this is the following. The integral, we say the integral, and the integration symbol is an S, and a long S, or an elongated S, stressed out S. We say the integral of the number 2 with respect to x. Okay, that's what this means. So this means the integral of the number 2 with respect to x is equal to the following. Now, we said that integration is the reverse of differentiation. So if we're calculating the integral of the number 2 with respect to x, what do we mean by that? We mean that we're looking for the function that we differentiate in order to get 2. That's what we're looking for. Okay, so in calculating the integral of the number 2 with respect to x, we are looking for, or we are calculating the function that we differentiate. We're looking for the function that we differentiate to get 2. Okay, so what function do we differentiate? What function do we differentiate and get 2? Okay, what function do we differentiate and get 2? Right? What function do we differentiate and get 2? The function that we differentiate to get 2 is 2x. Do you see that? The function that we differentiate to get 2 is 2x. Okay? It's 2x. If you differentiate 2x with respect to x, it'll give you 2. So then the integral of 2 with respect to 2 is 2x. The integral of 2 with respect to 2 is equal to 2x. Okay? The integral with respect to 2 is equal, the integral of 2x with respect to 2 is equal to 2x. Because if I differentiate 2x with respect to x, I get 2. So let me say this again. the integral of 2 with respect to x is equal to 2x, because the derivative of 2x is equal to 2. I'm going to say it again. The integral of 2 with respect to x is equal to 2x, because, okay, because the derivative of 2x with respect to x is equal to 2. Okay. All right. So that's how that works. Okay, sorry about that. Okay, so as I was saying, the integral of 2 with respect to x is 2x, because the derivative of 2x with respect to x is equal to 2. Now again, okay, again, if I take this 2x and I add a constant to it, let's say I add just a general constant to an arbitrary constant c. If I add an arbitrary constant c to 2x, any c basically stands for any constant. Now, if I differentiate this with respect to x, I'll still get 2. I'll still get 2, because the derivative of 2x with respect to x is 2. Okay, the derivative of 2x with respect to x is 2, and the derivative of c is 0, so it'll still give me 2. So then, because of this, the integral of 2, the general integral of 2 with respect to x is 2x plus c. Okay, so the general integral of 2 with respect to x is equal to 2x plus c. The general integral of 2 with respect to x is equal to 2x plus c. So that's how then we calculate indefinite integrals. We call this indefinite integrals. Okay, so that's how we calculate indefinite integrals. We call these indefinite integrals. All right. Let's go to the second. Let's go to the second one. Okay, let's go to the second one. Second example. Okay, example 2. Let's look at the integral of cos x. Let's look at the integral of cos x. Okay, the integral of cos x with respect to x. Okay, again, when we're integrating cos x with respect to x, we are looking for the function that we differentiate. We're looking for the function that we differentiate that gives us cos x. Okay, so we're looking for the function that we differentiate that gives us. Okay, so as I was saying, if you integrate cos x with respect to x, again, we are looking for the function that when we differentiate this function, we get cos x. Now, we've dealt with the derivative of trigonometric functions. we've dealt with the derivatives of trigonometric functions. So what function then do we differentiate to get cos x? It's obviously sine x. So sine x then is therefore our integral here, sine x. But then the general integral will be sine x plus c. So that's what we do when we deal with indefinite integrals. Okay, so that's what we do then when we deal with indefinite integrals. Okay, we find the function that we differentiate to get the function that we integrate. And this function is the integral of the function we integrate. Like in this case, we are integrating cos x with respect to x. So we find the function that we differentiate to get cos x. And since it's an indefinite integral, we add a c to show that this is a general solution. All right, we add a c plus c, okay, to show that this is a general solution. Okay, so the integral of cos x with respect to x is equal to sine x plus c because okay, the integral of cos x with respect to x is equal to sine x plus c because when we differentiate, okay, when we differentiate sine x plus c, we definitely get cos x. Okay, we definitely get cos x. All right, when we differentiate sine x plus c, that gives us cos x. And the sine x plus c is a general solution here. Okay, that's why we put sine x plus c, because that's a general solution. Okay, you see? So that's these are examples of indefinite integrals. Okay, these are examples of indefinite integrals. Now let's look at another example. Now this time, let's integrate 1 over t. What is the integral of 1 over t with respect to t? What is the integral of 1 over t with respect to t? Okay, now we know that when we differentiate the ln t, the derivative of ln t, the derivative of ln t is equal to 1 over t. So the integral of 1 over t is ln t. And of course, it's an indefinite integral, so we're going to add our plus, we're going to add our c, our plus c. So that's how indefinite integrals work, okay? And let's go to the next one. Again, we're doing examples now. Let's go to the next example and the last example, which is example 4. Okay, in example 4, we are integrating the function EU with respect to u. What is the integral of EU with respect to u? What is the integral of EU with respect to u? What function do we differentiate to get EU? Whenever we differentiate EU, we get EU. Okay, so we differentiate EU to get EU. So the integral then in this case is EU plus c. Okay, so now I hope you can see that. I'm hoping you're getting the hang of this, because that's how indefinite integrals work. So this is indefinite integration. This is indefinite integration. Okay, we call this indefinite integration. Okay, we call this indefinite integration. Okay, so now let's look at some integration rules. Okay, let's look at some integration rules. Now we're going to look at integration rules. Okay, so let's look at some integration rules. Integration rules. Okay, integration rules. Let's look at some integration rules. So now let's look at number 1. Okay, number 1. We are integrating the function x to the n. These are the rules now. Integration rules. What is the integral of the function x to the power n? So now we're integrating the function x to the power n. We're integrating it with respect to x. What is that equal to? The rule says that it's equal to the following. Okay, so now, as I was saying, guys, let me just see. Okay, so guys, as I was saying, the integral of x to the power n is some number. Okay, n is a number, and the integral of x to the power n with respect to x is equal to x to the n plus 1 divided by n plus 1. So this is a rule. And of course, it's an indefinite integral, so we're going to add a c. It's plus c. Okay? So the integral of x to the n with respect to x is equal to x to the n plus 1 divided by n plus 1. Okay? Now, obviously, the n is a number, but then note something about this number. Okay? Let's note something. Take a note here. The note is that this number n must not be equal to minus 1, because if it's equal to minus 1, then the denominator is going to be 0. So, and we cannot divide by 0. So therefore, this number here cannot be equal to, the number n cannot be equal to minus 1. All right? The number n cannot be equal to minus 1. So that's the first rule. If you're integrating x to the n with respect to x, that is equal to x to the n plus 1 over n plus 1 plus c, of course, because this is an indefinite integral, where the number n cannot be minus 1, or the number n is not equal to minus 1, because we cannot divide by 0. This is an important rule, okay? And of course, these rules, you will not get them in the formula sheet. These rules, you don't get them in the formula sheet, okay? These rules, you don't get them in the formula sheet. Let's go to the next rule, rule number 2. Now, with rule number 2, guys, you get the following. The integral of the function f of x. What is the integral of f of x? Plus minus g of x. The integral of the function f of x plus minus g of x with respect to x. What is that equal to? What is the integral of f of x plus minus g of x with respect to x? What is the integral of f of x plus minus g of x with respect to x? That is equal to the following. It's equal to the integral of f of x with respect to x plus minus the integral of g of x with respect to x. So the integral of f of x plus minus g of x with respect to x is equal to the integral of f of x with respect to x plus minus the integral of g of x with respect to x. That's how that works, okay? And the next rule is the following. What is the integral of c, a constant c multiplied by a function f of x with respect to x? So what is the integral of a constant c multiplied by a function f of x with respect to x? What is that equal to? Well, if you have a constant multiplied by a function, you can factor out the constant. You can take it out the integral, and then you're left with the integral of the function with respect to x. So the integral of c times f of x with respect to x is equal to c multiplied by the integral, is equal to c multiplied by the integral of f of x with respect to x. And as rule number 4, let's put this just to remind ourselves that, okay, the integral of a constant. What is the integral of a constant with respect to x? The integral of a constant with respect to x is basically equal to that constant multiplied by x plus an arbitrary constant. In this case, the constant is c. So, okay, let me change. I'm going to change this. I'm going to check, because I always use c for the arbitrary constant. So let me change this constant and write something else. Let's say a. The integral of a, a is just a number. It's a constant. The integral of a constant a with respect to x is equal to ax plus an arbitrary constant c. All right? Just to remind ourselves that if you're integrating a constant, this is what happens. Okay, so the integral of a constant a with respect to x is equal to ax plus the arbitrary constant c. So these are our rules here. These are our integration rules. Okay, these are our integration or rules of integration. And of course, what we're doing now is called indefinite integration. Indefinite integration. Okay, in indefinite integration, your integrals always have that plus c in them. There's always that plus c in them. That's indefinite integration. So now let's move on to the examples, the next set of examples. Okay, so now we move on to the next set of examples. We're moving on to the next set of examples. Let's move on to the next set of examples. We're moving on to the next set of examples. Example number 1. Okay, before we do that, let me just write the instructions. The instruction is evaluate. So the instruction is to evaluate the following integrals. Evaluate the following. The instruction is to evaluate the following integrals. 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 That's the instruction. Evaluate the following integrals. Okay, so let's start with the first one. Let's start with the integral of the following. So let's start with the integral of 2x squared plus x minus 4. Okay, so now we're evaluating the integral, the following integrals, starting with the integral of 2x squared plus x minus 4. What is the integral? What's the integral of 2x squared plus x minus 4? Okay, what is the integral of 2x squared plus x minus 4? Okay, what is the integral of 2x squared plus x minus 4? Okay. Okay. What is the integral? What's the integral of 2x squared plus x minus 4? What is the integral of 2x squared plus x minus 4 with respect to x? And this is how you evaluate this. So the integral of this, obviously, now you're going to integrate each term. Okay, now we're applying the rules that we just discussed. Now we're going to integrate each term. So this is going to be the integral of 2x squared with respect to x plus the integral of x with respect to x minus the integral of 4 with respect to x. So now the integral of all of these, of this function is basically equal to the integral of each of these terms, okay? So now, starting with the first one here, we've got a constant. Then the constant is 2. So now we're integrating 2 multiplied by x squared with respect to x. So we're going to take out the 2. We're going to multiply this by the integral of x squared with respect to x plus the integral of x with respect to x minus the integral of 4 with respect to x. Okay, so now we'll do the following. Okay, now let's work out the integrals. Now the first term, we've got 2 outside. Okay, we've got 2. Let's put a bracket here so we can put the integral in the bracket. The integral of x squared with respect to x is simply equal to x 2 plus 1. We're applying the rule. One of the rules is x to the 2 plus 1 divided by 2 plus 1. Okay, we'll close that. Now we're not going to put a plus c yet because we've got other terms to work out. We're going to put the plus c at the end. And then the integral of x over here is obviously equal to x to the 1 plus 1 divided by 1 plus 1. Okay, minus the integral of 4 with respect to x, which is basically equal to 4x. So the integral of 4 with respect to x is just simply equal to 4x. Okay, simple as that. Okay, no problem. And then now we can add the c because now we've integrated all the terms, so we can just add a plus c at the end because, of course, this is indefinite integration. So what is it, a plus c? And then we now simplify everything. Okay, so we've got 2. We've got the 2 plus 1 is 3. So this will be just 2 over 3 because it's x to the 3 over 3. So it's 2 over 3 multiplied by x to the 3. Okay, plus, and then now we've got x to the 2 over 2. So this will be just basically just x to the 2 over 2. X to the 2 over 2 minus the 4x plus, of course, the arbitrary constant c. So now we've got 2 over 3, x to the power 3, plus x to the power 2 over 2, minus 4x plus c. So that's the final answer then for this particular one. That's how you evaluate this integral. Now let's move on to the next one. Without wasting any time. Let's move on to the next one and see what the next one is. Okay, number 2. Let's go to number 2. Now in number 2, we are asked to integrate the following. So we're integrating the function t to the power 2 plus t plus 1, and we divide this by t squared. So the integral is the integral of t squared plus t plus 1 over t squared, and we're integrating with respect to t. Okay, so what we do first is that we divide t squared into each of these terms. So t squared over t squared is 1. Okay, plus, so it's t squared over t squared, 1, plus t over t squared, that's 1 over t, plus 1 over t squared, that's basically just t to the minus 2. Okay, 1 over t squared is the same as t to the minus 2. And we're integrating this, of course, with respect to t. So again, the integral of the sum is the sum of the integrals. We integrate each term. So this is equal to the integral of 1 with respect to t, plus the integral of 1 over t with respect to t, plus the integral of t to the minus 2 with respect to t. So we integrate each of these terms. The integral of 1 with respect to t is given by the following. It's a constant. 1 is a constant, so it's 1 times t, which is just t. Again, we don't put the plus c yet because we have other terms to integrate. The integral of 1 over t with respect to t is simply just ln t, okay? And we'll say plus the integral of t to the minus 2. Applying one of our rules, we've got t to the minus 2 plus 1 over minus 2 plus 1, okay? And so now that's all the terms. So now we add the c at the end, plus c, okay? And then we move on. We move on to see what the answer is. Well, that's the answer. We just want to simplify it. So t stays the same. That's t, and we got plus ln t stays the same, and we just simplify this term here. So the minus 2 plus 1 is just minus 1. So this is minus 1. So this will be minus here. And we've got t to the minus 1, which is the same as 1 over t. So we're just going to put 1 over t here, plus, of course, our c at the end. So this is the solution of this particular example. So this is how you evaluate these things, okay? This is how you go about evaluating these things here. This is how you evaluate these things. This is how you go about evaluating these things right here. So that's basically an introduction to indefinite integrals. Okay, that's the introduction that we're doing to what we call indefinite integrals. That's the introduction we're doing for indefinite integrals. Okay, so now what we're going to do now, since we looked at indefinite integrals, now we're going to look at what we call definite integrals. Okay, if there's indefinite integrals, the definitely is definite integrals. Okay, again, I'm going to say it again. What we've just looked at is what we call indefinite integrals. Okay, these are called indefinite integrals. So now what we're going to do is we're going to go into definite integrals. What are definite integrals? If these are indefinite integrals, then what are definite integrals? If these are indefinite integrals, then what are definite integrals? So let's look at definite integrals, okay? Let's look at definite integrals. All right, let's look at definite integrals. So let's look at definite integrals. So we put definite integrals. Okay, definite integrals. We looked at indefinite integrals. Now we're looking at definite integrals. Again, we've looked at indefinite integrals. So now we look at definite integrals. Sorry, let me just go back here. We have looked at indefinite integrals. So now let's look at definite integrals. Okay, what are these? Now, definite integrals are used to evaluate areas under curves. You can use them to differentiate areas. Sorry, you can use them to calculate. So definite integrals are used to evaluate areas under curves. Okay, so we use them for that. We use definite integrals for that. Okay, they are used to evaluate areas under curves. Okay, definite integrals are used to evaluate areas under curves. Okay, Um, of course, there's many situations where we use them to also evaluate volumes. It depends on the situation. So we can use them to evaluate areas under curves, or areas between curves, or volumes, volumes under surfaces, or volumes in between surfaces, stuff like that. Okay, so definite integrals are useful for that type of work. And any integral that you see, any definite integral that you see, can be interpreted as an area under a curve, or or a volume, depending on the dimension where you're working. Okay, depending on the dimension where you're working. All right. In this case, we're looking at R2. We're looking at the two-dimension the two-dimensional plane. So in this case, definite integrals evaluate areas under curves. We can interpret them as an area under a curve. Okay, so definite integrals. Let me finish the statement. Definite integrals. All right. So let me finish that statement there. Definite integrals. Definite integrals are used. I'm going to say it again. Definite integrals are used to definite integrals are used to evaluate. Definite integrals are used to evaluate. Definite integrals are used to evaluate areas. Okay, definite integrals are used to evaluate areas under curves. Okay, definite integrals are used to evaluate areas under curves. Definite integrals are used to evaluate areas under curves. Definite integrals are used to evaluate areas under curves. Definite integrals are used to evaluate areas under curves. Okay, so let me just do a little drawing of this. Just a rough sketch. That's our y-axis. This is our x-axis. Okay, so you can let's say this is our function here. Just a rough sketch. This is our function, and the equation of this function of this curve is y is equal to f of x. Okay, and that's a over here. Okay, and that's b over here, and the shaded region is this is the area. Okay, this is the let's say we want to calculate the area of this shaded region. Okay, let's say we want to calculate the area of the shaded region under the curve. So to calculate this area, you can use definite integrals. Okay, you can say the area of the shaded region. You can say area of shaded region. Area of shaded region. Area of shaded region is equal to the integral from A to B. So the area of the shaded region is equal to the integral from A to B. Okay, integral from A to B of the function f of x. So you integrate from A to B, and you integrate the function f of x with respect to x. So what that'll give you, this integral here, this integral here, now this integral here, it will give you the area. When you evaluate this integral, the result will be the area of the shaded region. It will be the area of the shaded region, which is of course which is the area under the function f of x between A and B. Okay, so this over here is called a definite integral. Okay, this is called a definite integral. It's an integral that has limits. Okay, it's an integral that has limits. Let me just go back here. This is an integral that has limits. Now, B is called the upper limit. The number b over here is called the upper limit of the integral. This is called the upper limit of the integral. And the number a is called the lower limit of the integral, lower limit. So an integral with limits, like this lower limit and this upper limit, that's called a definite integral. Okay? An integral with limits, an integral with a lower limit and the upper limit is called a definite integral. You saw with the indefinite integrals, there's no limits there. But then when you're dealing with definite integrals, okay, if you're dealing with definite integrals, you do have limits. You have a lower limit and an upper limit. So this is called a definite integral, okay? Okay, guys, let's go to the next thing. Let's look at now how to evaluate. Let's look at how to evaluating definite integrals. Okay, how do you evaluate definite integrals? How do you evaluate definite integrals? Now let's look at evaluating definite integrals. Evaluating definite integrals. Evaluating definite integrals. How do you evaluate definite integrals? How do you evaluate definite integrals? Okay, how do you evaluate definite integrals? Okay, evaluating definite integrals. How do you evaluate definite integrals? Okay, now if you have a definite integral, if you have a definite integral of a function f of x with respect to x from a to b, okay? So a is your lower limit and b is your upper limit. So if you have this, to evaluate this, you do the following. This will equal to the following. It'll equal to f of x. Now, f of x with a big with a capital letter f. F of x, it represents the function that you differentiate. It represents this function you differentiate to get f of x. Okay, so then the definite integral of the function f of x with respect to x from a to b is equal to big F of x evaluated. Okay, now this line is called, this is the line to denote evaluating. Evaluated from a to b. We say it's evaluated from a to b. And of course, what this means is it means the following. It means that this is equal to the following. It means that you evaluate your big F at b, and you're gonna say minus, and then you're gonna evaluate your big F at a. Okay. 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 So if you're integrating, so you're calculating the integral of f of x with respect to x from small letter a to from the lower limit a to the upper limit b, that is equal to big F of x evaluated from a to b, which is equal to f of b minus f of a. Okay, which is equal to f of b minus f of a. So now, and of course, as I said, the big F of x is basically the function that you differentiate to get f of x. So I'm going to say where, this is where the derivative of big F of x, where the derivative of big F of x with respect to x is equal, sorry, let me go back there. Where the derivative of big, wait, let me just do this. Where the derivative of big F of x with respect to x is equal to small f of x. Okay, so that's how this works. So this is how you evaluate definite integrals. This is the way that you evaluate definite integrals. The integral from a to b of f of x with respect to x is equal to big F of x evaluated from a to b, which is equal to f of b minus f of a. Okay, where the derivative of big F of x with respect to x is equal to small f of x. Okay, so this big F of x is just the function that you differentiate to get small f of x. So this is how you evaluate definite integrals. This is how you evaluate definite integrals. So let's look at now at examples. Let's look at examples now of this. Let's look at examples of this. Let's look at examples of this. So we say examples. Let's look at examples of this. Okay, let's look at example one. Example one. Let's look at the integral of the function cos x, okay? The integral of cos x with respect to x, right? And let's integrate from the number 0 to the number pi over 2. Okay, so we look at the integral cos x, and we're integrating cos x with respect to x. Okay, we're integrating cos x with respect to x, and we're integrating from 0 to power 2. So now, first of all, of course, we're going to apply what we've just looked at here. Okay, we're going to apply this. Okay, we are going to apply this. So now, what is the function that we differentiate to get cos x? What is this function that we differentiate to get cos x? The function we differentiate to get cos x obviously is sine x. So that's sine x. So now we're going to evaluate sine x now. It's from 0. We're going to evaluate sine x from 0 all the way to pi over 2. Okay. Now, what that is equal to, it's equal to the following. It's equal to, we can put a bracket around here. Put a bracket. Sometimes we put a bracket. So let's put a bracket. So we're going to evaluate sine x from 0 to power 2. Obviously, that means that we're going to say sine of pi over 2 minus sine of 0. Sine of pi over 2 minus sine of 0. Now, what is sine of pi over 2? Sine of pi over 2 is 1. Sine of 0 is 0. So this is equal to 1. So the answer is 1. So it's as simple as that. That's evaluating definite integrals is as simple as that. Let's look at another example. Let's look at how do we integrate? Okay, let's look at the integral of 1 over u. The integral of 1 over u with respect to u. So the integral of 1 over u with respect to u from 1 to 3. So we're integrating 1 over u with respect to u from 1 to 3. So what is this function that we differentiate to get 1 over u? Okay, what function do we differentiate to get 1 over u? What function do we differentiate to get 1 over u? The function that we differentiate to get 1 over u is ln u. If you differentiate ln u, it will give you 1 over u. Okay, so then we're going to take this ln u, we're going to evaluate it from 1 to 3 to get our answer for this. So of course, what this means, it means that we say ln 3 minus ln 1. Now ln 1 is 0. So this is basically just ln 3. Okay, ln 1 is 0. So this is basically just ln 3. And ln 3 is approximately 1.10. And we leave it there. That's our answer. Simple as that. That's how you evaluate definite integrals. Now let's look at something else. Let's look at something a bit more challenging than those two, but it's pretty much the same thing. So now we're integrating 9e to the power t with respect to t, right? And we're integrating it from ln 2 all the way to ln 4, all right? So now there's a constant involved here. So you can take out the constant, okay, applying one of the rules of integration, take out the constant, take it out the integral. And now you're left with the integral from ln 2 to ln 4, the integral of e to the power t with respect to t. What is the integral of e to the t? What function do we differentiate to get et? You can put the 9, just put the 9 outside, okay, and then work out the integral. So now, what function do we differentiate to get et? What function do we differentiate to get et? It's et. So to get et, we differentiate et. So then we just put et, and then we're going to evaluate this et. We're going to evaluate it from ln 2 all the way to ln 4. We're going to evaluate it from ln 2 all the way to ln 4. So let's put the 9 outside, and then let's evaluate. So this will be just e to the ln 4 minus e to the ln 2, because we evaluate this function from ln 2 all the way to ln 4. Okay, so now what happens is the following. So we put 9 outside, and inside we have the following. Okay, now e to the ln 4 is the same as this. Knowing that, you know, the natural exponential function and the natural logarithmic function are inverses. You know what happens here? You basically get 4. So e to the ln 4, it gives you 4. Because e and ln are inverses, so therefore they're inverse of each other. Okay, e and ln are inverses of each other, so therefore they give you 4. They will give you what's inside, which is 4. And then e to the ln 2 also will give you 2. You can check that in your calculator. Okay, e to the ln 4 is 4. E to the ln 2 is 2. So now we have 9 times 4 minus 2, which is basically just 9 multiplied by 2, which is basically just 18. Okay, so that's the answer we get here. So that's our answer here. That's how you evaluate this. It's as simple as that. So you see, guys, how simple this is? This is how you evaluate definite integrals. And basically, that is integration. That's the introduction that we're looking at. That's our introduction in this class. That's our introduction to integration. So that's basically integration in a nutshell. This is integration in a nutshell. This is the foundation of integration. We got the indefinite integrals. We got the definite integrals. All right. We got the indefinite integrals. We got the definite integrals. So we're going to stop here for now, and we're going to have another lecture on integrals and one more lecture. Okay, we're going to have one more lecture. I think it's one more lecture on integrals, and then that'll be our last lecture for this course. Yeah, okay. All right, thank you.